Thank you, Vicky. Hello, it's Carsten here for the second part of our Kea DHCP webinar series. Welcome. Good morning, good evening, good afternoon, wherever you are. Today we talk about installation, configuration, and basic setup of the Kea DHCP. And as Vicky already mentioned, I have a lot of stuff today, and it will easily fill the hour. And don't worry, at the end, I have possibly some slides where I will go quickly over them. These slides have some examples of commands in there. I will explain what the commands do, on what's good about them, but I won't go into all the details about the command line switches in there and such. If you have specific questions, please ask them at the end in the Q&A session, and I can go back and explain deeper if there's interest on one or the other command. So let's jump in. What is this Kea DHCP we are all talking about? It's a modern DHCP v4 and DHCP v6 server. It's of course open source. It's under the Mozilla public license as the other ISC products. And it's modern in a way that it has a JSON REST API. So it can be reconfigured from the outside via this API, and you can request statistics and other valuable information through the API. It's modular, so it doesn't contain everything in a monolithic program. Instead, you can just load the stuff that you really need, and that reduces the attack surface and also the complexity of the product. It is high performant, it's quite fast, and it has built-in failover either via an SQL database or via a special high availability hook. And it has support for host reservations and special support that we will look deeper into one of the next episodes in our series. It supports DHCP v6 and DHCP v6 prefix delegation. Dynamic reconfiguration. I just saw on the ISC DHCP mailing list a posting today about the older ISC DHCP, because that always needs to be restarted whenever you do reconfigure. That's not the case with Kea. You keep it running and you make your changes via the API or other means, and they will just happen in the running process. So no need to restart. It can, of course, do dynamic updates. It has a database backend, and it can do MySQL, PostgreSQL, Cassandra, and maybe more in the future. It has a statistics module that gives you all kind of pretty statistics that you can graph, and in one of the later webinar series we will show you Stork, which is an add-on to Kea that gives you a web interface to look at some of the statistics. And it does Pixie boot support. So that is Kea DHCP. What do you need to run Kea? It runs on these operating systems. These operating systems are officially supported, meaning that ISC is testing on them and making sure that it runs flawlessly on all of them. But it can run on other Unix-like and Unix operating system as well, such as macOS, other Linuxes like Alpine Linux, and also OpenBSD and possible NetBSD and Dragonfly and whatever all other BSDs are out there. The only exception currently is that it doesn't work on Windows. I read a rumor today, it's still a rumor, that maybe future versions of Windows will run on a Linux kernel. When that happens, of course, you can then run Kea on Windows as well. But that's a rumor. If you want to install Kea, you need a cryptographic library such as Botan or OpenSSL. That's for encryption support. Then there's a logging library called Log4C+, and the Boost C++ system library. If you install from packages, your packaging system will just make sure that all these dependencies are being pulled from the repositories and are installed. If you install from source, you have to make sure that all the headers and source components of these three items are already on your system. Optionally, you need a database. but you can also run Kea without a database, just with a lease file on disk. For large installations, it might be good to have an SQL database. We talk about sizing and decisions whether to use a database or not in one of our later webinars. There's support for Radius with the free Radius client. And if you use netconf and Yang, which is a modern replacement of SNMP, you can do that as well. And the Kea DHCP documentation, which is linked from here, has detailed information on the dependencies. So how do you install Kea? If you have one of the operating systems where Kea is directly in the operating system repositories, that might be the best choice. So if you have a Red Hat, Canonical, Ubuntu, SUSE, Linux, and Kea is already packaged there, you can just pull that in. It might be a slightly older version than the latest version that is being released from ISC, but depending on your needs, that might be fine. You can also install Kea DHCP from source. So for example, if you need special build configuration or the latest features that are not available as a binary package, you can do that as well because it's open source. In addition, ISC offers binary packages for the most popular Linux operating systems. That is in its own repository. So basically you configure an extra repository into your Linux system, and then the ISC build packages are directly fetched from there. And whenever there is an update or a new version, you will also get that with your update from the packet manager. So the binary packages from ISC, they are published at the same day as the source code. So if you use these ones, you are always on the leading edge with the bug updates and new features. The open source packages that you can get for free from ISC contain a couple of the hook libraries. The hook libraries are optional components that you can configure into Kea that then enable extra functionality. And we will look at some of these hook libraries in the later webinar series. And the ones that you see here on this slide, these come with the open source version of Kea. There are some additions to Kea, some hooks that are mostly of interest for large companies, enterprise companies, and these are available for support customers. Something like forensic locking or host cache or radio support, subnet commands, meaning that you can dynamically manage subnets through the API. These are in the support customer hooks, and you can get them by getting a support contract from ISC. So we already talked about the hooks. The Kea-based software implements the basic DHCP v4 and v6 functions. And that might be all you need. However, if you need more, you can extend this basic function through hooks. And they are called hooks because they hook into parts of the DHCP engine and can change the decisions of the DHCP server, or can even change the packets being generated by the DHCP server in certain access points where the packages go through the server's software. And you can either use hooks that are coming with Kea. There are third-party hooks that you can use. And you can even write your own hooks. That's how to write a hook. It's all documented and there are examples available. This hook system allows the core Kea system to stay lean, fast, and non-bloaty. And you can only then load the function that you really use and need, and that reduces the complexity and also the attack surface on your installation. For example, if there is a security problem in one of the hooks and you are certain that you don't use that hook at all, you even don't load the hook, then you don't need to care about updating your Kea because there's just one security issue in a hook that you don't use. And that's a good point. Some Hooks are part of the open source package. Some are premium hooks that can be purchased online from the website, and other hooks are available with the support subscriptions. And then there are third-party hooks that you can find as source code, for example, on GitHub, that other people have written for their needs, but they share that as open source. And you can download the source code and compile that into your Kea to make use of these extra functions. For example, I've seen a third-party hook that can shell out to whatever scripting language there is, Python, Perl, Ruby, whatever, work on the DHCP package and then feed that back into Kea to make custom decisions on a package coming in. That's not fast, but very, very flexible. The premium subscription hooks, they are available in source or binary form. And if you buy them, you can download the hooks for the next 12 months. It's important to recognize that the API, the interface between Kea and the hooks might change between versions. So if you have a Kea version, let's say 1.7, you should use the hooks for 1.7. It might work that hooks with a different version than the main Kea product work, but that's not guaranteed. You should always make care, if possible, that you use the hooks that have the same version number as the main Kea product. So next we have a look on a basic configuration, just a simple DHCP v4 configuration. First of all, the configuration file for Kea, for all the Kea modules, are in JSON. JSON is JavaScript object notation, which is an industry standard. There's even an RC describing JSON and an ECMA standard. And almost all editors and scripting languages have some support for this JSON format and can work programmatically with that. And the decision has been made to use JSON instead of some other format because it is so widespread supported. For an administrator, it might not be the easiest one to work with, but in the long run, I think it has its benefits, especially for scriptability and automation. So here, now we come later into what this snippet is really about. The JSON being used by Kea is an extended JSON. So it extends the JSON format with some additional feature that make it convenient as a configuration file format. For example, you have shell commands with the hash character, and everything after that is ignored until the end of the line, similar to other configuration formats. Then we have the C commands with -- and also the multi-line commands. So if you are a happy user of the bind name server, you know all that. Bind configuration supports the same. Also, you can include other subfiles into the main configuration files with the angle bracket != include syntax that you see here. Whenever you work with a JSON, it really makes sense to use an editor. And sorry, there is a formatting error here with the Vim. It should be just a bullet point. It's not that Emacs is equal to Vim. So you should have an editor that somehow understands JSON, because it makes it much easier working with JSON configuration files, because these editors then can check whether the configuration file is well formed, meaning that all the opening braces have closing braces and all the semicolons are in the right position and such. And almost most popular editors have that. Emacs, Vim, Visual Studio Code, and what people like. Only if you use very simple editors like Nano, they don't have that. So these very simple editors might not be the best choice. For Emacs, there is a JSON mode, and I put some information in here how to enable this. And for Vim, there's also the Vim JSON syntax highlighting that you can set on the command line inside Vim with set syntax equals JSON. The configuration files can usually be found under /Kea. That is true for most Linux and Unix systems. However, there are some that have their own locations, like the BSDs. They put everything that doesn't belong to the base operating system in user local etc. So because Kea is not part of a FreeBSD based system, you find the configuration file in user local etc Kea. But if you are a FreeBSD user, you might already know that. These are the main configuration files that we have in Kea. There is the control agent, there is the dynamic DNS updater. We have the DHCP4 server and the DHCP6 server, and we have Kea Control. And Kea Control is special in the way that the configuration is not in JSON format, but it's a shell script format. We will come to that a little bit later. But all the others, the first we have seen here, the first 4 are in JSON format. The configuration files that are provided with the Kea packages and also in the source code, they contain extensive commands. So just by reading the example configuration files provided by the project, you can learn how the configuration works. And in addition to that, there's a full documentation that you can find on kea.readthedocs.io. And that is linked here. And I highly recommend, if you start working with Kea, at least to skip over the documentation and read some parts of it to get a feeling how the documentation is set up and what's in there. So now we come to a basic DHCP4 configuration example. It starts with a block of DHCP4, and then we configure the interfaces that our DHCP server should be listened on. In this case, it's a Linux machine, and it has one Ethernet interface called ETH0, and the DHCP4 server should listen on that network interface. And next, we configure a control socket. A control socket is the interface to the tools from the outside that talk to the Kea services. That can be Kea Shell, that can be Kea Control, that can be your scripts that talk via JSON with this socket. And here we have a Unix socket. It could also be an iNet socket listening on the network. This is very similar if you are familiar with the bind name server with the RNDC control statement and the control channel to remote control a bind name server. So this is the equivalent for Kea. Then we define our database, and the simplest one is to have a memfile database, which is the lease database in memory. And here we see just a simple lease database configuration where everything is stored in memory. Of course, that's not recommended for production use, because if your server is being rebooted, your lease file is gone because it's just in memory. There are other options like using a full-blown SQL database or using a lease file on disk. Then we have global configuration options. And these apply to all the subnets and all the pools that are in the DHCP server, such as the rebind and renew timers and the valid lifetime of the leases. And then the main part of every Kea DHCP configuration will probably be the subnets and the pools in there. And that is another block, a subnet 4 for IPv4, a subnet 6 would be for IPv6. The subnet has a name here being the base address and the network mask. And then inside the subnet, we have the pool addresses. That is the range of IP addresses that are given out by the DHCP protocol. Here we have 100 addresses between 192.0.2.100 to 200. And inside that pool, we define DHCP options. Here, that's the router option that defines the default gateway for the clients. And we can put any number of options in there. And then logging. Kea, similar also to the bind name server, has a very flexible and powerful logging framework. So you have a different like categories that you can log, and you can define where you want to log, either to a file or to syslog or similar, and you can define the severity and debug level for each one. So that is very powerful and should be good for the most logging needs of administrators. And that concludes the basic configuration. So we have the network setup, the control sockets, then we have global configuration, we have our subnets and pools, and we have logging, and that's all we need to start with Kea. Of course, from there, it can grow complex very fast because we have complex networks. And if complexity rises, it's important that we are able to check for any errors in our configuration file before we reload our server and apply the new configuration. And Kea makes it easy by having a built-in syntax checker. When you start the Kea services with a -T option on the command line, then it will not start, it will not reload, it instead will just load the configuration file and will give you a report whether that configuration file is being readable or contains any syntax error. Here we have an example of how we test the DHCP v4 configuration file. We start Kea-DHCP4, which is the process binary for the DHCP4 server, -T for testing. And then we reference the configuration file. And in this example, there was a missing, or there was an extra closing curly brace at line 33, character 9. And then we can fire up our editor and search for that and fix it. If we have fixed it and we start again, we should see similar output like this one, which is a little bit wrapped to fit on the slides, but we see that it's listening on the interface, and that it gives some informational warning there, and that one new subnet has been added with the parameters given there. So I recommend to make it a habit or even automate that whenever you change your configuration, first test before reload. Speaking about starting, reloading, restarting, and stopping Kea, Kea comes with a shell script that you can use to control all the different Kea services, because Kea is not a monolithic service. It has modules. There's one process for DHCP v4, there's one process for DHCP v6, there's might be another process for doing dynamic updates to a DNS server, something like that, and you want to either stop or start all these services together. If you use Kea Control, you need to be careful to not conflict with any process supervision services such as systemd or runit or S6 that is running as well on your service, because if you, for example, run systemd and you have configured systemd to have your Kea always running, and if you then stop with Kea Control, Kea Control will just bring down the processes, and systemd will recognize this and will immediately start the processes again. So if you run any of these supervision services on your Linux or Unix system, best is to use not Kea Control, but to use the commands from systemd or runit or S6. But if you have a classic System 5 or RC or OpenRC system, then Kea Control can be really handy. So the configuration file for Kea Control is not JSON. It's it has the simple, I call it a shell script configuration syntax. You just add some configuration variables in there. And I think it's actually it's a file that is sourced by a shell script. And here we configure the location of the configuration files and the location of the binaries. And then in the second part of the configuration file, we define which services from Kea we want to start. So here we have the DHCP v4 and v6 server, but no dynamic DNS updates. We want to have the control agent, but not netconf, and we don't want to have verbose logging on. Once we have the configuration in place, we can use Kea Control start to start these services, and Kea Control will then print one line for every service it starts. And with Kea Control status, we can then query which modules are currently active and running, and where to find the configuration files of each of the modules. And when we did changes to the configuration file and after checking for errors, we can use Kea Control to reload the configuration. This will not stop the services and restart them again. It will send signals via the control channel to the services and tell the service to reload its configuration without stopping. And if we need to stop the services, we can do so with Kea Control stop. Easy enough. If you use systemd, you probably have a systemd unit called Kea DHCP4 and Kea DHCP6 and Kea agent, something like that. So you can use systemctl start, status, stop, the usual systemctl commands to start the services. And if you have systemd, I highly recommend to use that then instead of Kea Control, because they can conflict if you use them both in parallel. And here's the output of systemctl status, Kea DHCP, and this is how it looks like on a modern, I think that was a Red Hat 8 system. So now we have a DHCP server running. How do we test that it is really working, that it is answering DHCP requests? And this is not Kea specific. This is a best practice tip that I give in my trainings, how people can test their DHCP server. And it's easy enough, and it works with the ISC DHCP Client, which is a separate software package from ISC that is the de facto standard for most Linux and Unix systems. So if you have a Linux or Unix system that does DHCP client side, it usually has the ISC DHCP client installed. So it's nothing that you need to install extra. The client program is called DH Client, and we can use that tool as a simple debugging tool. You need to know that DH Client doesn't itself reconfigure the network stack. Instead, it does the DHCP protocol with the server, and then it sets a couple of environment variables and feeds the variables to a shell script. And that shell script has then the does the work to configure your Linux or Unix system. And we can make use of that in the way that we create our own shell script, a very, very simple one that only has 2 lines. It has the shebang line that defines it as a shell script. And then it has one command, the env, the env command, which prints the environment, all the variables that are passed to the shell script. It will do nothing else. It will just print out to the standard terminal output all the values of the variables that DH Client has set. And then we make the script executable. And then we can run that script. We can run DH Client, and we specify the script file with -sf. SF is for script file. And then we specify our own special debugging script. And that script will then be called with all the variables, and it will print out all the data, all the options, the IP addresses that it has received from the DHCP server. And that is a very easy troubleshooting tool that is pre-installed on almost all Unix systems, and it's easy to use because you don't need to install anything, and you just have to write a 2-line shell script in order to make yourself a good DHCP troubleshooting tool. it's important that this will not reconfigure your client machine's network stack. So you can safely use that even via a network. So even if you are SSH'd into a machine, you can use this to test your DHCP server without the danger that you cut the network. If you have more needs in terms of testing, especially performance benchmarking, Kea comes with a Perf DHCP, which is a DHCP benchmarking tool. And that tool can be used to benchmark Kea, but also any other DHCP server out there, because it just talks the DHCP protocol as fast as it can. And if you want to learn more about that, there is the documentation linked from this slide. Now we have a running DHCP server, and we know how to stop that and to get the status. But with Kea Control Agent, we can now interact with the running Kea services. The Kea Control Agent is the process that provides the REST interface. And with the Control Agent, we can then change and reconfigure the Kea services without restarting and without going manually in the configuration files with an editor. And this is very handy, especially if you then use some front-end systems like the ISC Kea Stork system that we will show in one of the later webinar series. The control agent communicates via the Unix control sockets that we have seen in the beginning. So this is the configuration of the control agent. By default, it's listening on the loopback interface, port 8000, but you can reconfigure that in the configuration file and open that to your network. By default, it's only on the loopback address for security reasons, so that nobody accidentally opens the control interface unauthenticated to the whole internet, for example. That would be bad. There is also Kea Shell, which is a Python command line tool that you can use to interact from the command line with the Kea Control Agent. It talks the REST API, and it spits out the JSON data that it receives from the Kea REST API. So here's an example using Kea Shell, asking for the DHCP servers on the loopback host on port 8000. And the command we sent is version get. And here the output from Kea Shell is being piped in the JQ command. JQ stands for JSON query, and it's a command line tool which is independent from Kea. It just comes with most Linux and Unix operating systems, and you find that in the repositories. It's usually not installed by default, but it's part of the repositories of almost all Linux and Unix systems, so you can easily install that. It's very lightweight and small. And what it does here is that it pretty prints the output, because by default, Kea Shell will just print everything in one line. It might be hard to read, and JQ makes it nicely indented and easy to read. And we will see that we can use JQ for other tasks later on in this webinar. So the REST interface has really been designed to be used from a configuration application, something like Stork or the Kea Shell, or your own written like Ansible playbooks or SaltStack or Chef recipes, or you write maybe your own web interface for Kea with PHP or Python. Because it's JSON, it should be quite easy to do if you have some skills in writing a web application that does talk to a REST API. However, you can also talk to Kea from the command line just with the curl tool. Curl stands for client URL. It's the de facto standard tool on Unix from the command line to talk anything that is web or is an API. And here we have an example how to send a config get command to a Kea service running on the loopback interface port 8000. Now this is handy to test from the command line against the API. It's not really meant to use this as the main configuration interface, because that would be really complex. But to do quick requests and test out the API, that's fine. But using Kea Shell or using Stork or using other configuration frontends are better suited for that. Here we use again the JQ tool to get a pretty print output. And you can also filter specific parts of the output. For example, here the config get fetches the whole configuration file from the Kea server. And with the filter .0 arguments DHCP4 or DHCP4 loggers, we just get the snippet that defines the logging and not the whole configuration file. And these kind of filters, it takes some time to get used to it if you are not a JavaScript/JSON developer. But after time, you might find that helpful to easily from remote request some configuration snippets from your server. Another command that is available is the list commands, and that will give you a list of all the commands you can send to your Kea server, which depends on the hooks loaded and also on the modules that are currently started. So here we ask for the commands of a DHCP4 service, and that will return a list of all the API commands that are available. Now I will show the workflow, and that is the very basic workflow just from the command line, how we can use the REST API to fetch the current running config from a server over the network, then change the config and write the config back towards the server, just with command line tools. First step is to fetch the whole configuration. And we have seen that before. We sent a JSON request with command config get to the DHCP4 service to a server running on the loopback interface port 8000. And then we filter for the first part. The 0 means that we want to have the first array in that JSON. And we dump that out into a file called Kea DHCP.temp. And that is then the whole configuration file for the DHCP4 service. Then we can use a text editor. We go into the file, and we add at the beginning the command and the service file or statements. The command is config set, and that means that with sending this JSON snippet, we want to override the existing configuration. And we want to do that for the DHCP4 service. Then we make changes to the configuration. We can even remove parts of the configuration that is in the file if we don't want to change anything there. And important, at the end of the file, there is a result structure that is the result from the config get request. We have to remove that because it doesn't make any sense to have a result in a request in the config set command that we sent in. So once we have done that, we have changed the configuration, we can then specify that Kea DHCP.temp file and send that back to the Kea control agent. And we pipe the results again in JQ, and it tells us result is 0, no error message, and the text's configuration was successful. That is what we want to see. Now, when we do these kind of dynamic changes, all the changes are stored in memory, and they are not immediately written back to the config file on the server, but we can tell the server to write its running config back to the configuration file. So whenever it restarts, it will then read that changed config back. So we do so with the config write command. Now be careful here, if you have a configuration file that you have handcrafted with a lot of commands in here and a special formatting, if you do a config write, that will all be gone, because the Kea DHCP server will just write the internal representation of its configuration to the file, and it will do so in its own way of formatting the JSON output. So don't use this if you plan to manually work with your configuration files. So a little bit about the DHCP v4 configuration. The DHCP v6 configuration. The DHCP v6 configuration is very, very similar to the DHCP v4 configuration, so there's not much differences. And the DHCP v6 server is completely independent from the v4 server. It's a different process. So you can decide to either start one or the other or both. They can be run on the same machine, and they won't interfere, and they won't stamp on its others configuration or something. That's completely safe to have both running on the same machine. The configuration file, of course, is different. It's keadhcp6.conf instead of keadhcp4.conf. And you can also control that server in the same way as you can control the DHCP v4 server, either through the script or through systemd. And you can change the configuration in the same way as I've shown that for the DHCP v4 part. One difference is that in DHCP v6, every server has a unique UID, the DUID. And if you ever reinstall your DHCP v6 server, because you might do a completely full upgrade of your operating system or such, and you wipe the previous installation, it is a good idea to back up first the DUID from the system, so that all the clients will just recognize the new server as being a replacement for the old server. And the DUID is stored in the Kea-DHCP6-server ID file, which lives in var lib Kea on most Linuxes and Unixes. But that path is system distribution independent. If you don't find the Kea-DHCP6 server ID file in var lib Kea, search with find in your, it should be somewhere, and the name is unique. You should only see one file of that name in your installation. Yeah, so maybe I was a little bit too quick because it's just 45 minutes. These are the next webinars. The next webinar, we have lease allocation. So we talk about how Kea actually figures out which client gets a lease and what lease from which pool. We can have fairly complex rules inside Kea that controls how leases are given out. We talk about client classifications so that we can tell apart different client types. For example, we can separate routers from desktop machines, and we can separate mobile devices from TVs and such, and how we assign option and different option values. End of October, we have high availabilities and the database backends. In November, we talk about monitoring, logging, and the Stork web front end. And in December, it's all about migrating from the previous ISC DHCP server, the older one, to the new Kea DHCP. And now you can fire your questions at me.
Okay, we actually have quite a few questions.
That's good.
Yeah. In the future, so it appears that Zoom now allows participants to answer questions in the Q&A panel. So in the future, we'll try to get all the questions in the Q&A panel and just use the chat for comments. So Tomek has been answering quite a few of the questions for us, but I'll just run through what we have in here so far. First of all, Jim was asking whether or not there's support for Red Hat 7. Yes, there is.
Yes.
The ISC packages include a package for Red Hat 7. Red Hat 6, however, is EOL. So we have actually support for both 7 and 8. Samuel had several questions related to the APIs. He noticed that there was a change from the 1.6 branch to the 1.8 branch. And in particular, it sounds like he had some process that was parsing the lease statistics, and that broke. And Tomek's response is that we really try to avoid introducing any backward incompatible changes. When we do introduce a backward incompatible change, we always highlight it in the release notes, and we only make those kind of changes in major versions. So that's really the purpose for having a development branch. Tomek, if you would like to answer any of these questions live, you can feel free to chime in. We have another question from Stefan, whether or not Ubuntu is supported. Ubuntu is supported. We have a package for that. There's another question, which I think I'll just leave to let people read about the socket naming in the Q&A. It's answered. There's actually a very good question from Stefan about reloading. What happens if you try to reload a Kea configuration and the configuration is invalid? Tomek, would you care to answer that one live?
Yeah, sure. So in principle, Kea Control is just a shell script that communicates with Kea. The communication capabilities are limited, so it's implemented as a signal. So this is one way how you can trigger reconfigure. Another one is that you can use the config set command directly, as Carsten was showcasing. So this is probably slightly better because you have the feedback. So you can get the information whether the configuration was successful or not. And if it wasn't, you also have an error message that will give you some clues of what exactly failed. And if you do this with just Kea Control, you don't have this information. So, but anyway, getting back to the specific question, Kea will try to revert back to its previous configuration. In many cases, this is possible, but sometimes it's not. So like I can give you two specific examples. For example, if Kea shuts down the connection to a database, tries the new configuration and it's broken, and it then tries to revert back to the old one. Then Kea has to reestablish the connection. But if the database refuses the connection, Kea is not able to really revert back to this old configuration, and then Kea will basically get stuck in an unresponsive state. So it will be clearly reported that it's unusable. So yeah. Okay, also one more thing. There are two things that you can do to test your configuration. There's a -t option in the command line, so we can start Kea in the test case, in test mode, let's say, to test it. And there's also a command called config test. Again, this is not completely bulletproof, but it covers most of the cases.
Okay, actually, Tomek, perhaps you could answer. So there's one question about the file path, but I think we don't need to read that out. It's easier just to read the answer. There's a follow-up question from Samuel that's still open. Is there a way to use the Kea DHCP v4 command to dynamically load a config file? For instance, in my main DHCP v4 config file, I'm using statements to include the network's JSON file. So that the include statement was in fact covered in the webinar. So really the question is it possible to import a new JSON file via the include without doing a reload?
It depends really from, Tomek can maybe chime in there as well. From my experience, it depends on which part the JSON file is describing, but sometimes it's possible and sometimes not. So yes, it depends on if there are maybe dependencies in there. You don't need to load a complete configuration file. You can just update specific stuff in a configuration.
Yes, that seems to be correct. So we previously looked at various approaches here. So one was that we are considering whether we could specify an optional file name in the config reload. So you could point to a new file that you want now to load a new config file. But this has some potential security implications. So, and we decided that it's not really needed so far. But if you have a specific use case, I encourage you to submit a feature request on our GitLab, and we might implement it.
Okay, well, that's the last of the questions. And I want to thank you very much, Karsten, for another excellent webinar. And I hope that we will see you at the next webinar. This recording will be posted. Typically, they're up by Friday. I've put the location in the chat.
Thank you very much. Thank everyone for listening. Have a good day.